Imagine a spy so small it could land on your fingertip, and you'd never even know it was there. A silent observer, a discreet gatherer of information, all resting comfortably on your hand. It's not an insect, buzzing and flitting about, but a sophisticated machine, engineered for a specific purpose. These are microdrones, the cutting edge of surveillance technology. They're tiny, silent, almost imperceptible, and designed to blend seamlessly in with nature, mimicking the forms and movements of insects and birds. This isn't some far-off science fiction fantasy. It's real technology, actively under development in labs and research facilities right now, pushing the boundaries of what's possible. The smaller the drone, the stealthier it becomes, a shadow in the sky, almost invisible to the naked eye. They're able to slip effortlessly through cracks, infiltrate buildings with ease, navigating complex environments undetected, and gather intelligence undetected, providing a constant stream of information without raising suspicion. Forget the drones you see in parks, buzzing around for recreational fun. These are sophisticated tools, specifically designed for surveillance and espionage, pushing the limits of what's possible in covert operations. The race to miniaturize is pushing the very limits of engineering, demanding innovation at every level. It's making the line between nature and machine almost invisible, blurring the boundaries of what we consider to be alive and artificial. Imagine sending a scout into a hostile building through a window crack, gathering intel before a team even sets foot inside, or deploying a swarm of these tiny devices to search through disaster rubble, locating survivors in the most challenging conditions. Microdrones represent a quantum leap in remote, discrete information gathering, offering unprecedented access and insight. Their power comes directly from their size, the ability to be unseen, unheard, and virtually undetectable. The smaller they are, the bigger their potential impact on surveillance, security, and even warfare. Nations around the globe are investing heavily in this technology, recognizing its strategic importance. But China is making headlines with a drone reportedly as small as a mosquito, pushing the boundaries of miniaturization. A mechanical mosquito, a tiny buzzing spy in the sky. It's designed specifically for surveillance, a covert monitoring device unlike anything we've seen before. This technology could fundamentally change everything we know about privacy and security. So, how exactly do you build something so incredibly tiny, packing so much technology into such a small space? What exactly can it do? And what are the limitations of this groundbreaking technology? And what does it ultimately mean for a world where the walls might not only have eyes, but also wings, capable of seeing and hearing everything? Let's dive in and take a closer look to see what makes this technology so incredibly powerful and potentially disruptive. The future of spying is here, and it's smaller than ever before. So what is a microdrone? It's not just a shrunken toy drone. Micro air vehicles, or MAVs, are unmanned aerial vehicles small enough to fit in your palm, or smaller. Their goal to be so tiny they're mistaken for insects or go completely unnoticed. In surveillance, detection is failure. Microdrones are nearly invisible to radar and can mimic natural sounds. They slip through security, infiltrate buildings, and observe from inches away, access that was once impossible. The secret is biomimicry. Engineers study insects like dragonflies and mosquitoes to copy their flight mechanics. This makes microdrones agile, stable, and energy efficient. Nature is the ultimate engineering guide. Microdrones aren't just flying cameras. They're platforms for sensors, cameras, microphones, thermal and chemical detectors. They can reach places no human or conventional drone can. That's what makes them revolutionary. Their true power is where they can go, and what they can see. The age of the invisible observer has arrived. Now, let's focus on China's Mosquito-Sized Drone. This isn't just a concept, it's a real project, backed by the Chinese military. Weighing less than a gram, with a wingspan of just a few centimeters, it's designed to look and move like a real insect. The goal? A virtually undetectable reconnaissance tool. These microdrones can gather intelligence, identify targets, and listen in on conversations, without ever being seen. Every component, from the body to the power source, is miniaturized to the extreme. China's investment is part of a broader push for technological superiority in AI and robotics. Swarms of these robotic insects could create invisible sensor networks over battlefields or cities. It's a bold vision that could change espionage and warfare forever. How does a drone, especially one as small as a mosquito, actually work? It seems almost impossible, doesn't it? To pack so much functionality into such a minuscule frame requires some truly ingenious engineering. Traditional propellers like those on larger drones simply won't cut it at this scale. They're too inefficient and create too much drag. So, drawing inspiration from nature, engineers often use rapidly flapping wings, mimicking the flight of insects. These wings are powered by incredibly small piezoelectric actuators. These actuators precisely mimic the action of insect muscles, providing the necessary force and control for flight. This flapping wing design creates lift both efficiently and remarkably quietly, making these drones difficult to detect. For vision, the drone uses a camera that's often smaller than a grain of rice, an incredible feat of miniaturization. The camera often employs a compound eye design, directly inspired by the multifaceted eyes of insects, allowing for a wide field of view. An onboard processor, itself a marvel of engineering, stitches together the images from these tiny lenses to create a wide-angle view of the surroundings. The drone transmits the captured data via a tiny low-power radio link, conserving precious battery life. This data is then sent to a nearby receiver, which could be a larger, more powerful drone acting as a relay, or a ground operator monitoring the situation. Everything, from the wings to the camera and transmitter, is powered by a thin-film lithium battery, maximizing energy density in a small space. And the entire operation is coordinated by a sophisticated microcontroller acting as the drone's brain. This microcontroller manages the complex task of flight, processes the incoming images, and handles all data communication. All of this functionality is packed into a package that's often lighter than a common paperclip. Some of these advanced drones even have basic autonomous capabilities, such as obstacle avoidance, allowing them to navigate complex environments. Every single part, no matter how small, must work in perfect harmony with the others for the mission to succeed. It's truly a marvel of microtechnology and precision engineering. The engineering challenge involved in creating these devices is immense, pushing the boundaries of what's currently possible. But the result is a fully functional, insect-sized surveillance tool capable of gathering information in places previously inaccessible. This represents the cutting edge of surveillance technology, offering unprecedented capabilities. The future of surveillance is here, and it's incredibly tiny, blurring the lines between science fiction and reality. Where would you use this technology? Imagine the possibilities, the scenarios where having eyes in the sky, no matter how small, could make all the difference. The possibilities are straight out of a spy thriller. Think of the covert operations, the clandestine meetings, the need for discreet observation. In a hostage crisis, a swarm of Mosquito drones could map the building, providing crucial intel before action is taken. Locate hostages, pinpointing their exact location within the structure. And identify threats, assessing the number and position of the captors, giving rescuers a real-time edge, allowing them to formulate the most effective plan of attack. For counterterrorism, a drone could perch on a windowsill, blending seamlessly into the urban landscape, providing hours of undetected surveillance, gathering vital information without raising suspicion. In disaster relief, hundreds of microdrones working in concert could search rubble for survivors, tirelessly combing through the debris. Using thermal cameras and microphones, detecting faint signs of life beneath the wreckage. To guide rescuers, leading them directly to those in need of immediate assistance. These aren't just tools for war, they are versatile instruments with a wide range of applications. They can save lives, offering hope in the most desperate of situations. On the battlefield, microdrones scout ahead, providing invaluable reconnaissance, spot ambushes, alerting troops to hidden dangers, and assess damage, quickly and efficiently evaluating the impact of enemy fire, without risking soldiers, keeping them out of harm's way. They're expendable, disposable scouts, easily replaced if lost or destroyed. That changed the risk calculus for every operation, making missions safer and more effective. The intelligence they provide is precise, offering a clear picture of the situation on the ground, timely and invaluable, providing decision-makers with the information they need when they need it most. Microdrones are redefining what's possible, pushing the boundaries of technology and innovation, in both combat and rescue missions, proving their worth in a variety of challenging environments. They're not just gadgets. They are sophisticated tools designed for professional use. They're game changers, transforming the way we approach security, rescue, and defense. The impossible mission just got a new secret weapon, a technological marvel that levels the playing field. The future of intelligence is smaller, more discreet, and harder to detect. Smarter and everywhere, providing constant vigilance and situational awareness. Welcome to the era of the invisible scout, where information is power and knowledge is the ultimate defense. But shrinking technology comes with big challenges. Power is a major hurdle. Tiny batteries mean flight times are short, often just minutes. Limited range means operators must stay close, sometimes risking exposure. Flying something so light is tricky. Wind, rain, or even a closing door can send it crashing. Durability is a concern. These machines are delicate, and even a small collision can be catastrophic. Environmental factors like dust, moisture, and temperature can easily disable them. Countermeasures are evolving. Jammers, microwave emitters, and even anti-drone swarms could neutralize microdrones. The cat-and-mouse game of military tech never ends. For every new spy tool, there's a new way to swat it down. Building robust, reliable microdrones is a huge challenge. The race to stay ahead is relentless. Every advance brings new obstacles. The future of microdrones will be shaped by how we solve these problems. What does this mean for our future? Microdrones signal a seismic shift in surveillance and privacy. For now, they're military tools, but miniaturization and cost drops mean they'll soon be everywhere. Imagine private investigators, corporations, or even individuals deploying swarms of microdrones. The potential for misuse is staggering. Corporate espionage, paparazzi invasions, and the end of privacy as we know it. Our laws aren't ready for a world of invisible autonomous flying sensors. How do you regulate what you can't see? Who's responsible if things go wrong? We need new rules and ethical guardrails, fast. The Mosquito drone is a symbol of both human ingenuity and the risks of unchecked surveillance. It can save lives, but it can also create a dystopian world of total observation. The choices we make now will shape the future. We must decide how to balance innovation with privacy. The age of tiny flying eyes is coming. The real question, who will be watching?